Hello, Tom from EveryStepCalculus.com, EveryStepPhysics.com. Another example of Green's theorem, and show you how that pathetically works in life. Index 8 to get to my menu. I'm going to scroll down to Green's theorem. Generally in a test they give you what you're supposed to solve or use Green's theorem or something like that. So we choose Green's theorem and we enter our x and y or I and j functions. And this one is, you have to press alpha before you enter anything into my entry lines here with the calculator, okay? Alpha, and it's 3 times x squared plus y and 3 times, for the j or y value, 3 times x let's see, did I press alpha? Alpha. 3 times x times y squared. Imagine the knucklehead professor that's stood around for 2 weeks taking up these functions here that would work with what they're asking you to do, which is find the area of a triangle, which is 1/2 base times height, in reality. So anyways, I say it's okay, I give you a chance to change it. The m or the p function is 3x squared plus y. The q or the n function is 3x y squared. They use those different letters for depending upon which professor you're talking to and which book you're looking at. And the partial of m, I use m here. Partial of m with the partial of y is 1. Partial of n with the partial of x is 3y squared. And we subtract those according to the formula. And it's 3y squared minus 1. And we're going to choose, I'm going to go up, press the up cursor to go to the bottom of the menu to get to triangle. That's what's in the problem. This was a Yahoo problem. Object within the region is a right triangle, okay. And what did they give you? They gave you either 3 points or they give you this y equals x equals. In this case, it's the first one there. I'm going to choose that. And I'm going to go alpha 0. That chooses the boundary. If you've ever worked Green's theorem, that's the most difficult thing, is to figure out what the boundaries are. And that's, the second one is alpha what? Alpha x. Third one is, the x value is alpha 1. Say it's okay, and we do the Green setup. This is what we found here before with the partials and over these regions, dy dx. So we integrate dy, and then we, over the range that was given, which is x and 0, turns out to be x cubed minus x. Cubed minus x. And then we integrate dx, which is x cubed minus x, with respect to x, over the range of 1, 0. And we do that, and so the answer is minus 1/4 square units. Pretty neat, huh? Every step calculus, EveryStepPhysics.com. Don't try to pass calculus without my programs. Believe me, it's much easier. They cheat you, you cheat them. Have a good one.